as Nina said, I'm a professor at, I'll try to go quickly because I know we're over time. I know people have other things to do. So as I said, I'm a professor at Hanyang University here in Seoul, Korea. So if you don't know, if you're not familiar with Hanyang University, it's like a top 150 school in the world. If you care about university rankings, it's kind of like the MIT of Korea. We're really good at engineering and computer science, but not that good at anything else. So yeah, I'm an associate professor here in the Department of Intelligence Computing and Data Science, and I'm also an adjunct professor at DePaul University in Chicago, where I used to be, and now I have an honorary title where I'm still technically there, but I'm not really there because I'm here. So you know how academia is. We all like to have lots and lots of titles. So that's kind of my background. So I'm here. I came here a couple years ago. They recruited me over here to teach things like data science and machine learning and robotics, human-robot interaction. And that's what I taught in the United States before this. I was at DePaul University. Before that, I was at Indiana University. So yeah, so that's my background. As I also mentioned, I've spent a lot of time in industry as well. I was a senior data scientist at several major healthcare companies like Cigna and CVS Health and Centerstone. So I've spent kind of my career kind of going back and forth between industry and academia. So I kind of have the perspective of the industry side because I've been a data scientist for years, and then I've kind of have the academic side where I kind of see kind of what's kind of going on at the bleeding edge. So depending on what you want to do. I even spent some time in the startup world, which was interesting. So anyway, so one thing that's interesting about having spent that time kind of going back and forth between all this stuff is, I kind of started doing what people call machine learning and stuff back probably around like 2002, 2003. When I first graduated from college, a little bit older than I look. But I remember programming neural networks and Bayesian networks. This was back before Python, before scikit. We used to have to do weird things where we would like code like a Bayesian network into a database using SQL and set up the tables as our conditional probability tables and do all this kind of crazy stuff just to get things to work. I remember hand coding neural networks in Perl. That's still around. So, it's been interesting to watch the change over time because I've been doing it now for 15 or 20 years. It's been really interesting because really for the first 10 years until like 2011, 2012, people just call me crazy, honestly. We'd send papers to journals and they'd be like, well, where's the p-value for your statistical test? And we're like, well, there is no p-value. It's machine learning. We got lots of data and we built models. And then, it's been interesting in more recent times because now everything's kind of changed a lot, right? And I've had my own successes. These are some things I've done, back, 5-6 years ago, and some things I'm still working on. But things have changed quite a bit, right? I mean, as things have become more popular, and now everybody's a data scientist. My grandma, she passed away now, but she would joke she's a data scientist because she would make pies, and she had to use a recipe to make a pie, and a recipe is like an algorithm, and so that's like data science. So it's interesting how the changes happen. Really, somewhere around, I don't know when exactly, but like 2013, 2014, 2015, everybody started to say, oh, I do AI, I do machine learning, I do data science, all this stuff. Whereas for the first 10 years, people were like, you're nuts, right? So what is interesting, I think, for people who've, just kind of getting into this, or people who are, interested in this stuff in the present time, is a lot of this stuff is becoming more and more commoditized, which means that there's a lot of noise, right? When I spent time in the startup world, one thing that was really frustrating is there were so many people claiming to do things that were just vaporware. And I hate to say this, but even some of the large organizations, I won't name names, some of the big tech companies, they're more bluster, more hype than actual capability in some ways. And so then even if you have something that's tangible, something that's actually of value, you're left sort of standing in a crowd full of people yelling that they all do the same thing. And increasingly too, I think that a lot of this stuff is going to become automated. I teach data science students, and I constantly tell them, like, you don't want to do what people have been doing for the last 5 years, because if you do that, by the time you graduate, there's not going to be a place for you in terms of opportunity, right? So I think what's interesting, given all that, is that it kind of begs the question of where should we focus our attention now? And so, I give this talk or a similar talk from time to time, and for me, that's the real interesting question, right? For most people who want to do this, is the opportunity never lies in what people have already done. It lies in the things that people have not done yet. So the question is, what is that? And so hopefully today, in the short time that I have, I can talk a little bit about some of these opportunities, right? So one opportunity I think is really important is that you can kind of take some inspiration from nature, right? If we look at how the human brain works, right, it's pretty clear that it doesn't run one type of algorithm, right? A lot of guys have probably heard terms like deep learning and machine learning and reinforcement learning and all these other things, Markov models. But what's really interesting is if you look into the cognitive science, it's that the brain is clearly combining, maybe not these algorithms per se, but it's combining sort of forms of these algorithms, right? It's very clear that what's going on in the perceptual parts of the brain, like the visual cortex or the auditory cortex, is very much akin to like deep learning. But what's going on, say, in the cerebral cortex, like the anterior frontal sulci, is much more akin to something like Markov decision processes. And what's going on in the basal ganglia, where our sort of dopamine reward system fires, is more akin to reinforcement learning, right? And I could go on with many other examples, but the point is that it's very clear that nature long ago figured out the best way to create things that are really intelligent is by combining lots of different kinds of algorithms together, right? And so that's where I think a lot of the opportunity is in the future. You see so many people talking about deep learning or machine learning or all these different things, but really the opportunity comes from combining them together, especially as these things become more and more commoditized, right? I have students who are working on deep learning projects right now, and it's funny because some of the stuff they're doing, I'm like, I did the exact same thing 5 years ago. Right? I mean, yeah, we've added a few things here and there, but really what makes them more capable nowadays, or where the opportunity really lies, is when we kind of combine them with new types of data, or we combine different types of algorithms together, right? It's just like an automobile, right? What makes modern automotive technology so amazing is that we took all these different components and we kind of formed them into their own self-contained parts, and then we combined them together. Right? And that's how we kind of create this really impressive modern technology. Modern cars, modern automotives are actually quite stunning pieces of technology, right? And so it's kind of a perfect example of the kinds of probably paths that we're going to take as we develop AI and robotics and machine learning and develop them into sort of products and services and solutions in the coming years. And so I think people who can figure out this kind of stuff are people who are going to have a lot of opportunities in terms of exploiting AI and stuff like that. Now, I've kind of been talking a little bit more broadly, but a lot of my background is actually specifically in healthcare, right? So I do lots of stuff, but 90% of what I do, 80%, 70%, I don't know. A lot of what I do is specifically focused on healthcare. So this talk, I'm going to kind of go from this broad view of how I think this stuff is changing over time and focus in on where I think some opportunities are, in particular in the healthcare space, right? Kind of related to some of the things that I've been talking about so far, right? So one of the real opportunities, I think, again, getting back to this idea of combining together new types of algorithms, new types of data, kind of in the same way that I was talking about the way modern cars do, is that, a lot of there's increasing research pointing to the effects that everyday environmental contaminants have on people, right? And we know this if you guys are familiar with a lot of the research on like the gut biome, right? Or on, I'll show you some examples here in a second, or on the effects of just simple air pollution on people's long-term health consequences. Having come from North America to East Asia, where the air quality is not the highest, I can see a lot of this very obviously, right? There's a lot of sort of side effects to these things, right? But a lot of you guys, if you're familiar with some of the research on the ways like the gut biome affect a lot of different diseases, it's really interesting, right? There's even people arguing now that things like diabetes are actually an inflammatory disease, right? And things like multiple sclerosis or other types of neurological diseases are actually because there's a bacterial imbalance in our digestive tract, right, our gut, that's actually causing these sort of disturbances to our immune system, and therefore causing lots of problems, right, from our own immune system attacking parts of our own body, right? It's all tied to these kind of environmental contaminants. There's even an argument to be made with coronavirus that that's part of what's going on, right? It's why there's some evidence that vitamin D is actually improving the health outcomes of people, because vitamin D actually has the same effect on people who have autoimmune diseases, largely by mitigating the gut microbiome, right? Because vitamin D is actually not a mineral, if you know, it's actually a hormone. So all this stuff is really, really interesting, right? Again, these new types of data. Well, like I mentioned, right? There's a study that came out last year from the University of British Columbia pointing out an example of this I thought was really interesting, pointing out that just simply living near major roads is a major risk factor for lots of different neurological conditions, right? And if it was just one neurological condition, you'd be like, well, maybe it's something going on, but it's very clear that these people living near these major roads where there's lots of more air pollution, right? Why is it causing this whole swath of diseases, right? All these are very, very different diseases with different, sort of biochemical sort of biological pathways that cause them, right? And it's really curious to see how all these sort of environmental things are causing these kinds of disturbances, right? Even for diseases that have a genetic component, right? There's this environmental trigger, right? There's evidence of that in multiple sclerosis. And like I said, people now are arguing for diabetes that it may actually be an inflammatory disease. It's really, really interesting. It's not a scientifically settled debate. But again, we see this across the board with lots and lots of different chronic illnesses. What goes on in our environment around us is having a huge impact on our health, right? And so some people may say, well, it's interesting that's coming out scientifically, but we don't really have evidence to say that. Well, that's true, right? We can't come to a conclusive statement about it, right? But if you look through history, there's lots of people coming up with things that either made sense or didn't make sense because they lacked the ability to gather the evidence, to gather the data and model it appropriately, right? It's not that people in the past were stupider than us, right? It's not like we all of a sudden got smarter. It's simply that we've developed tools and technology that allow us to answer these questions and then come up with solutions for these problems. In the same way that we see all these things that I'm talking about, it's not clear what's going on, but it's clear that there's something going on, and that indicates that there's probably an opportunity. And if somebody develops the tools and technology to figure out the mechanisms, then there's a serious opportunity to kind of solve them, and potentially for those who are interested in business opportunities and investment opportunities, there's an opportunity here as well. So this is something we work on here in my lab here in Korea at Hanyang, and then I work with people all over the world. I work with people in the United States, at Indiana University and Mississippi State. I have partnerships with people in Germany at TU Aachen and TU Berlin, and Japan and all over the place, right? Chicago, everywhere, right? So a lot of what we do nowadays is we do this sort of human-robot interaction stuff where we develop these robotic pets, right? And these robotic pets, we equip them with these sensors. You can see an example here on the right, and then we put them into people's homes, right? And a lot of what we're trying to figure out right now is, can we detect these kinds of signals from the environmental data by using these sort of robots as sort of walking sensor suites, these robotic pets. I give you something you can play with, and then I can use that to collect data to understand the mechanisms that are affecting your everyday health, right? Like some of these environmental contaminants, what you eat, your diet, your exercise patterns, like that, right? Because health is something that happens every day. It's not something that just shows up when you go to a doctor's office. It's not the clinical data you're going to get from the hospital. It's not, you know, the genetic data that you're going to get the one time you collect your genetic data in your life, right? It's what goes on each and every day. Health is an accumulation of choices that we all experience. You're experiencing it right now, so am I, right? And so what we need is this window into people's everyday health, right? And this will probably come in many forms of technology, right? I mean, smartphones, wearables, other types of technology. But I think robots definitely have a part to play in this, right? As part of this AI thing. And again, many different platforms. These are some other robotic pets that we work on right now in various studies, right? And all of these are generating data, right? That we can then do the kinds of machine learning and deep learning kinds of stuff that you guys are probably familiar with and heard about. But what's really interesting to us is generating new types of data and interesting types of data about things that we've never really been able to see before, right? Another example, this is actually a Samsung robot called Bali here in South Korea. Not all robotic pets look like pets. Just say that, right? So this one rolls around and does stuff. But it's interesting all these kinds of devices and how we might be able to leverage them to do lots of interesting things, like to find patterns in people's data, right? Like to find patterns in people's circadian rhythms. Because what we find when we look into the data that we get from these robots is that when we have somebody who's normal, like the person here on the left, versus somebody who's not normal, like the person on the right, even a small set of sensors can pick up disturbances in the environment and in people's daily that indicate that something's not right. You know, what's not right? Well, that's where the machine learning and the deep learning and all that kind of stuff comes in. But we can clearly see just from visualizing the data that something's not right. And then we have to try to figure out what these patterns mean. And that's, you know, as a scientist, that's what I'm interested in. Obviously, people in the business world probably interested in how they can leverage these opportunities. But like I mentioned before, we live in this world of devices now. So it's not just robots, right? There's devices all around us. You know, lots of you guys probably have some of these things, you know, various smart TVs and smart fridges and smart home technology, right? And most of you guys have probably interacted with some of these things here on the screen, you know, Alexas and Fitbits and wearables. And you guys probably all have a smartphone. All of these are sources of data similar to the kind of robotic data that I'm describing that we can use for, you know, similar type of stuff, right? This whole smart home environment, right? So we can think about, you know, the real power comes from this sort of Internet of Things approach. The robots aren't going to live in a vacuum, but instead, we're the real kind of where I'm excited about, sort of long-term future, is we combine the data from lots of different devices, right? It's not just your phone, and it's not just your wearable watch, your Samsung watch or whatever, your Apple Watch. It's not the robot, right, or your smart TV. It's all these things combined, right? This sort of Internet of Things type of thing. It's really going to open up new frontiers and opportunities, and people are kind of playing around with it, but I don't think we've fully got to a point where we understand the true possibilities that are going to lie down the road. We're just now starting to figure this stuff out. You know, This is another group, another project I work with. It's called BioEffect. I work with these people back in Chicago. Actually, the paper I was just working on before I hopped on here was a new BioEffect paper. But this is an example of some of the stuff where we're trying to map people's mental health rather than their physical health, just looking at their passive keyboard dynamics, right? And this was in the Wall Street Journal, I guess, a few years ago. But but it's really interesting, all the things we can find out just from really innocuous forms of data. You just play with your phone, you don't have to do anything, and we can find out lots of things about what's going on in your daily health patterns, right? So a really rich ecosystem is emerging, and I think there's lots of opportunity here for many people to get involved and create new products and services to create value for our communities, right? As a scientist, that's what I care about most, is how can I create value for the communities that I'm part of so that we can all hopefully live better, happier lives, right? And I think that's, long term, there's going to be, I think we all kind of know in the future, we're not going to just go to the doctor's office. Like, we can all kind of see this stuff coming down the road, right? But healthcare is eventually going to shift outside the clinic walls. The question is exactly how. I don't know the full answer, and I don't think anybody knows the full answer, but I think all the things that I've talked about today are definitely part of this, right? So I won't say too much of this in the interest of time, but everybody knows privacy is always a concern. So I don't want to throw all this stuff out here without mentioning that we definitely do need to be concerned about privacy. And these are definitely big issues, the ethical side of data science. We can't leave out that part, but I won't talk about it today because we don't really have time in this short talk, but I'm sure all of you guys have heard people babble about it. I will say a couple of last things about this. So this is usually a longer talk when I give it, but but I'll just mention a couple of things. So I have some crazy speculative ideas that I don't know if they're that crazy, but again, people have been calling me crazy for a long time about things I think people aren't really working on just yet, but I think will come to fruition, I think, in the near future. One of those, Eric Topol has been talking about this for a long time, and Vinod Khosla, about this whole cyborg clinician thing. I'll just say this. I think that the sort of the HCI interface problem, the sort of way people interact with healthcare, AI, sort of technology, it's an unsolved problem. I think people are focused heavily on let's build models using machine learning and deep learning and all this, but really nobody has yet figured out how to communicate the results of this stuff effectively to the people who actually make decisions, which are the doctors and the patients themselves. People are working on it, and we work on it some ourselves as well. But I think this is really an open question of the best way to approach this stuff. How do we actually interface with people in a way that's going to persuade them to adopt the sort of solutions that we've found? How do we tell them a story that's really going to captivate their imagination and get them to buy into what we're trying to sell? And I think there's opportunity here for somebody, to figure out exactly how should this interface be. Should we just have screens flying around in front of us like Star Trek? Should it be something simpler? Should it actually be a screen, a touch screen? Should it be something that appears on a mobile device? Is it an app? Is it a computer you sit down? Should we have portals? Should we have windows? How is this going to work? I don't think this is a solved problem, and I think it's one of the limiting factors for a lot of AI and machine learning and stuff in healthcare. So I think this is an opportunity for somebody to work on. Another opportunity, I think, as people continue, crazy speculative opportunity, as people continue to make the push to move into space, I think 20, 30 years down the road, there's going to be a real need to have technology that can actually be deployed remotely. And maybe not even just space, maybe just to more rural environments all over the world where people are a long distance from healthcare, right? And so, this is an example. People are doing this kind of telehealth stuff in outer space now, and it kind of works, but it's not going to work when people are on the moon or on Mars or farther away. So this is kind of a limiting factor as well for humans to kind of pursue some of our more aspiring dreams as a civilization, to go beyond the planet, right? So I think all these are kind of things where people aren't really working on them, but I think people should start working on them, because I think in coming years, 10 years, 20 years. I think there's going to be a real need for somebody to figure out, well, how is this going to work? When we're in space and we don't have access to the internet, how are we going to build things that can actually solve the problem? And how do we not end up with something like this, right? Because we definitely don't want 2001 Space Odyssey, right? So I'm going to wrap up there. I hope you guys enjoyed the talk. Before I take any questions, I'd like to thank all my collaborators. I don't work on all this stuff alone. All the people at Indiana and Germany and Mississippi State and people in Chicago, and of course all my fantastic graduate students and undergraduate students here at Hanyang. Want to make sure I acknowledge all the people who help me do what I do. And if there are questions or anything, or if you want to contact me or get in touch with me, you're more welcome to email me or reach out. So thank you guys.